Today we are going through all the different ways that you can integrate. That means we got to go all the way to page 55. Okay, that's where we're going. We're going to page 55 today. Let's do this. Because the truth of the matter is you got to know how to integrate in order to be able to do anything else, okay? Remember, integration is the opposite of taking the derivative. So now it's like we're given the derivative function. Now we're trying to find position or the original function, okay? So let's just start it off. Of course, like I said, antiderivative. Anti-differentiation is the reverse of doing the derivative, okay? That is what integration is called. The original power rule for integration, remember, this is where you add one to your exponents, and then you divide by the new exponent, okay? We do this at the very, very beginning of the year, and then you always have a plus c whenever it's an indefinite integral, because that c can represent some type of constant, okay? When you have multiple pieces or like a multiple function that you're trying to do the antiderivative of, such as like x squared plus x dx, all you do is you do the antiderivative of each individual piece. So the antiderivative of x squared plus the antiderivative of x. Okay? Constant multiple rule. If you have a number in front of a function that you're trying to do the antiderivative of, you can basically bring that constant to the front and then just do the antiderivative with just x squared, not so much with the 3. Lastly, the derivative of any constant is always that constant times x. And then, of course, your plus c. You always have plus c whenever you have an indefinite integral. And that's the one without the bounds. So then for this one I've written here in green, when I'm trying to do the antiderivative of x squared plus x, remember you add 1 to your exponent. So 2 plus 1 is 3. You divide by the new exponent. The antiderivative of x to the first power. 1 plus 1 is?
Squared over 2.
So it'll be x squared over 2, and then you'll have your plus c, and this would, in the purple, would be the antiderivative of x squared plus x. Remember, you add 1 and you divide. This can also be written as 1/3 x to the third plus 1/2 x to the squared plus c.
There's 1 over the exponent.
Remember, because it was 1 over your new exponent.
I don't remember dividing it.
Yeah,
I didn't remember dividing it by that. Now I remember 1 over.
Yes, all right. So then it'll be 1 over n plus 1 x to the n plus 1. Now, actually, I think this is how it's written in the reference booklet. Because this is in the reference booklet. Okay. All right. So let's practice some. Let's start basic. On your desk. Let's go. X to the third. All right. What's the antiderivative of x to the third?
X squared over 4 plus.
Do not forget your plus c.
Oh, that was one of our mottos.
Plus c. Always plus c. Okay? Now for this one, what are you going to have to do before you can actually take the antiderivative?
Chain rule.
No.
Put it up in the numerator thingy.
You bring it to the top. You make it negative. Sorry, I missed the integral sum, but I forgot to delete it all. Okay? So you want to take the antiderivative of t to the negative 2. Do that real quick. So be careful on this one. When you add 1 to your exponent, this becomes what?
Negative 1.
And then you're going to divide this by a?
Negative 1.
So then your answer is negative 1t to the negative 1 plus c. Or when you write it with the exponent not being negative?
1 over negative t and then add c.
Very good. Awesome. Okay, let's do this one.
Oh, we're getting to the momentum, boys and girls.
Okay, how can I rewrite this? X to the what?
4 over 5.
4 or 5. So then you add 1 to this. So what's 1 plus 4/5?
9/5.
And so when you do 1 over 9/5, you have to flip your denominator, and so that becomes
It's 5 over 9.
x plus 9 over 5 plus c. Yes?
Yes.
Oops. Ooh.
I drew.
Wait, what happened? Do it again.
Rationalize it? Do we leave it like that?
Say what?
Do we have to like expand or do we leave it like that?
You can leave it just like that because it's a positive exponent. You don't have to worry about putting it back into the radical form or anything like that. Okay, let's get to the one that's a little bit more involved. Let's do this one.
Ooh.
Okay, we got this one?
Yes.
What's the antiderivative of, so basically you take the antiderivative of each part. What's the antiderivative of t squared?
T cubed over 3.
T cubed over 3 or 1/3 t to the third. This one turns into t to the,
1/4.
1/4.
so when you add 1, that becomes,
Yeah.
so your exponent is 5/4. What's your coefficient?
4/5.
Very good. And you cannot forget your,
Plus C.
I think you guys are getting this. Y'all, it's coming back, it's coming back, it's coming back.
Slightly.
What about this one right here?
What?
That's it.
What?
0.
What number's in front of this dt?
1.
And this is a constant, right? So what's the antiderivative of a constant?
1 plus
Constant
X
times-
plus C.
It's going to be your variable times your constant. It's t actually because it's dt. Then don't forget your plus c. So if it had been 3 dt, it would have been a,
3T plus C.
Oh.
so don't let that throw you off,
Oh.
okay? There is a number there, that number, the imaginary number, which is 1. So don't forget about it. Okay?
But if there's a number in front of the d, we can just take that out of the whole equation, right? And then we can
And that would be this.
just distribute it after.
Exactly. All right. Let's do this one. Reviewing from before and now.
This will be easy, boy.
What does this notation mean?
Derivative.
Remember, derivative is when you take the exponent and
You subtract 1. No, you just multiply it by the exponent.
What did you do?
And then the next exponent, you get that value minus 1.
okay. So yeah. So remember, derivative. You got to bring down the exponent and then subtract 1 from it. This turns into x to the negative 2. So then this becomes
Negative
8x to the negative 3. So then your answer is 3x squared minus 8 over x to the third for your derivative. No plus c needed or anything. But then here you're actually taking the antiderivative, which means you do what to your exponent?
Exponent.
1 over.
Put 1 over the
N plus.
n plus 1.
N plus 1. What is n plus 1?
4.
4. So it's going to be x to the,
4.
and then with the x to the negative 2, the 4x to the negative 2, that turns into,
Minus 4 over x. Because technically you moved out the coefficient.
because you add 1, so that becomes a negative 1. Then you divide it by a negative 1, and that's how you get that. What am I missing? Don't forget your plus c. How many are still forgetting plus c? 6 problems later.
Francisco is.
Plus c.
Oh,
That's
Like I do
the-
everything right, and then I get happy, and then I realize that I would have gotten the whole thing wrong because I missed a C.
No. Well, don't forget the c, because c basically creates a general solution. That's why we have to put in the constant. That's what the indefinite integral is, okay? And there's always a constant that gives us a general solution. Now, when we want a specific one, they'll give us some other type of information, such as this. It says, given that y prime is equal to x to the 4th plus the 4th root of x, and y equals 10 and x equals 1, we want to find y in terms of x. In other words, we want the specific solution here. We want the specific equation here. So to do this, we're going to take the antiderivative of the function. Okay? What's the antiderivative of x to the 4th?
1/5 to the 5th over 5.
1/5 x to the 5th plus,
Oh, there it is. Plus
Ooh, there it is.
4 x to the
X to the 5/4.
very good, 4/5 x to the 5/4. Then you have your plus c. Technically, this is your equation. Now, just in case you missed how we got that 4/5 part, remember that's x to the 1/4. You add 1, that's how you get 5/4, and then you divide it by the new exponent. That's what causes it to flip. Okay? Now, if I want the actual specific solution, I use 10 for y and 1 for x to find the value of my constant. You guys remember us doing this earlier this year?
Yep. And let me tell you, it's. Oh, wait.
Okay? So we already know that 1 to any power is just 1. So this is nothing but 1/5 plus 4/5, which is what? 1. So what's the value of c? C is 9. Now you just can't stop here. You actually have to write the equation y in terms of x.
But you put it in the
Not the derivative, you plug it back into the antiderivative.
So if it was asking for
Because
y,
this is
like
essentially
y
the basic.
prime in terms of x prime, then you would do the derivative, right?
Mm-hmm. But they wouldn't actually do all this to do that. So this is here, you'll plug in that constant. Now you have a specific equation that is the antiderivative of this situation. Okay? And remember, you can always check your antiderivative by actually doing the derivative. Bring down the exponent. What's 5 times 1/5?
1.
1, and then you subtract 1 from your exponent. What is 5/4, bless you, times 4/5? 1. You subtract 1, so you'll get x to the 4th plus x to the 1/4, and what's the derivative of a constant?
0.
And boom, you're back to.
Dang.
Square uno.
All right, I want you guys to do this one. All right, so remember, b of t is what?
Your OG function.
Yes, but it's also it's the derivative. So when we do the antiderivative of this, we're actually finding s, position, displacement. Okay, so when it says that s is 12 when t is 3, that means you have the point 3, 12 that you'll need to plug in to find the expression. So what's the antiderivative of 3t squared minus 2t?
T cubed minus t squared minus 6.
Plus C, you're there finding.
Oh, sorry, I accidentally found the thing already.
Yep, so then that way we can plug in 12. But I believe you're right.
Maybe.
3 squared, or 3 cubed is 27. 27 minus 9 is?
18.
So C is going to be a
Negative 6.
negative 6. So then your equation is S equals T to the 3rd minus T squared minus 6. Very good. Questions? Is it coming back?
It is.
Yeah.
Most definitely.
Okay. All right. Here are some of your special antiderivatives. Remember, e to the u is antiderivative is still e to the u, but don't forget your plus
Whenever
c.
we just say e, we might as well just say it's just the same. Because it's just chilling.
And remember 1 over u du or 1 over x dx. So that was ln of the absolute value of x plus c. Now, did they count off the absolute value? No, they really don't. But just to let you know, remember, because you cannot take the log or the natural log of a negative number. So it's always the absolute value. Always absolute value.
And likewise, if we're doing the antiderivative of ln, it's 1 over u, right?
Right.
So just vice versa. It just goes back and forth.
Okay? So we're going to look at a few of these, and then we're going to move on to some of the fancier antiderivative ones.
I forgot we had so many rules.
Use
Okay.
substitution.
This one's a pretty straightforward one. What's this one?
2 ln of x.
No,
LN
wait.
2.
Plus c. Don't forget your plus c. 2 ln of x plus c. Okay?
I was waiting for you to say.
This can be written as 2 times the antiderivative of 1 over x dx. That's why it's 2 ln of x plus c. Don't forget your plus c. This one, be cautious. What's the antiderivative of this one together?
ln of 4t. Plus c.
But I heard 2 different things from you guys. What'd you say?
ln of 4t plus c.
No, not ln of 4t.
1/4
Yes.
1/4 ln.
1/4 ln t plus c. Because this is the same thing as saying 1/4 times 1 over t dt. So that 1/4 is nothing but a constant that you pull out. Okay? What would I do here?
Okay, so we already have an original function, so let's just FOIL it and then find the antiderivative of that.
Very good. Don't forget that foiling is always an option to expand 6 and 6 make 12. So then you're actually finding the antiderivative of this whole function. So don't forget that's also an option. Okay? How would I do the antiderivative of this?
Take out an x.
You can't because there's different spot.
How would you factor? No?
You can find it.
Isn't it the same as saying 2x to the 3rd over x plus 6x squared over x plus 5 over x?
Yes. You can split it up. And you can simplify this way before you ever take the antiderivative. So x to the 3rd over x turns into what?
2x squared.
So this is nothing but 2x squared. Then this one turns into what?
6x.
Just 6x. But then that 5 over x will stay 5 over x when you take the
Because
antiderivative.
we're adding them all, you can just do them separate.
So don't forget, because there's not really like a quotient rule with antiderivatives. So you gotta think of the different ways that you can simplify your function before you actually do
You
the
gotta use the
antiderivative.
power streets, Maurice.
So in these, we don't have any chain. We don't have any.
Remember we had U substitution for this one, and then we had a few special rules that we'll get to in just a second. Okay. This one. What do you think I have to do before I actually take the
L and
antiderivative?
V already cancel out, so you're just left with U squared.
Yep. Don't forget about that. We're not doing these all the way out, but you gotta think. What are the other methods, algebraic things that I can do to simplify before I can actually take the antiderivative? Ooh, what about this one?
Okay, so
Can you split it up again?
What do you mean?
EX over 2 plus 1 half.
Okay. So if I split it up like this, this part, this 1/2 part is easier to do. But what about that e to the x over 2?
Doesn't it stay the same?
Just take out 1 half.
Yep. That's the same. They're saying 1/2 e to the x plus 1/2. Very good. Okay. Trying to get those things to trigger back. Okay. This one I actually do want you to do on your desk. Do this one.
3.
So remember, x square root of x is the same thing as saying x to the 1/2. If you split this up and you divide every piece by 1/2, remember when you divide exponents, you do what to them? Subtract. So really and truly, this becomes x to the what?
3/4.
3/2.
3/2. This one becomes x to the,
the halves.
and then x to the negative 1/2, because you got to bring it up in order for you to be able to do anything with it, right? Okay. So the antiderivative of x to the 3/2 is
2x 5 over 2 over 5.
Oh, okay, I see how you're saying it. So you're saying 2, then x to the 5/2, and all of that's over 5.
You completely and utterly, definitely understood me.
Okay, good. All right. Add x to the 1/2, when I add 1, that becomes
2/3 x to 3 over 2.
very good, 3 over 2. And then what's the antiderivative of the next one?
2x to the 1/2.
Is it minus or plus?
Plus.
Plus, because when you add 1, it becomes x to the 1/2, and you got divided by 1/2, and that's how you
You
do
were
it.
bad when that was
C.
Good job, Francisco.
I had it written down.
Francisco, you remembered plus C. I forgot.
Holy moly.
Now, these over here, these are not in your reference book.
Oh,
These were the special cases.
I'm gonna write that down.
These are the ones that you need to write down. And then I include the trig ones with it as well. So these are some of the special ones, okay? These all involve a linear something in the problem. So like here you have a linear factor raised to an exponent. Okay, so that other problem that we had, that was like 2x plus 3 to the second power. We could have also used this formula to figure out the antiderivative. But remember, it's 1 over a being the coefficient that's attached to your variable. So the antiderivative of this would be 1 over 2 times 1 over n plus 1. So you still add 1 to the exponent. So this would be 1 over 4. Then your linear factor of 2x plus 1 raised to the 4th power plus c. So then you just multiply the 1/2 and the 1/4 to get 1/8. 2x plus 1 to the 4th power plus c. If you forget this rule, you could always use
Use substitution.
you could use substitution or binomial expansion. Expand the binomial and do the antiderivative of that as a last resort.
What's use substitution? I forget that.
If you have e to the 4x minus 1, again, that 4x minus 1 is a linear factor. So you do 1 over a, which would be 1 over 4, e to the 4x minus 1, and then plus c. That's probably the easiest one out of the group. And then if you have 1 over a linear factor like 1 over 3x plus 2, it's 1 over a, so it'll be 1 over 3 ln of 3x plus 2, and then you'll have your plus c. The trig ones work the same way, negative 1 over a cosine, and then 1 over a. No,
Those are not in our.
none of these on your, none of these on this page are in your
That's
reference.
probably the tougher stuff.
Now you know basic sine, basic cosine, those antiderivatives are in your reference book, but not these.
Oh, okay.
No cards.
All right, so let's do.
Yeah, boy. That's old, isn't it?
let's do this one.
Okie dokie.
So that's 6. You guys know that 6 is nothing but a constant, so you can pull it out. Okay? So that'd be 4x minus 3 to the 7th power dx. So then you can apply your rule. The first one, where it's 1 over a. What's a?
4. Dash was number.
Then 1 over n plus 1, which will be
1 over 8.
the linear factor raised to the,
8th power.
and then you had your plus c. So basically you're multiplying 6 times 1 times 1 divided by 4 times 8
So it's 3 over 16.
because you would reduce it. 4x minus 3 to the 8th power plus c.
I'm still worthy. Use substitution. Jeez.
Did you do it?
Yes.
Why would you use substitution?
What? How
Because
do
it's
you
the way that works for me.
How do you do use
I don't
substitution?
remember
You.
substitution.
Andrew,
We're going to go over, that's the last thing we're going to go over today.
Oh,
It's coming up though because we're on slide 31, so it's coming.
Oh.
Alright, so for this one.
Let's do that for the final, or
Yeah, for the final one.
so we don't need it for last year.
No. I'd rather get to them now instead of waiting.
In your mouth.
Alright, so you want to make sure that you pull out that 2/3. So when you pull out that 2/3, you end up with this. Okay? This is one where you cannot use the ln.
Okay, so that's why we make it a
You cannot because this is not a linear factor. It's being raised to the 3rd power.
But
So you have
use
to do-
substitution.
Not yet, because I don't know.
Andrew, stop! We get it!
Bring it to the negative 3rd power, and then you can use the first rule out of all those rules, which is 1 over a. So 1 over. There you go. Okay, so this is what you'll have once you apply the rule. This simplifies down to be negative 112.
4x minus 5 to the negative 2.
And I can make that positive by bringing it back down to the denominator.
Plus C.
And then plus c.
Geez.
Yes.
Solving.
Wow,
Alright,
you're
the
being racist
substitution.
against all the other methods now, aren't you?
Substitution method is basically when you have a function within another function, and on top of that, you actually have the derivative of the function, of the inside function in your actual problem. Okay? And so this is where we basically substitute in a variable for the inside function, and then when we take the derivative of the inside function, it appears a part of the problem. So we're going to spend some time because the last bit of what we're going to go over today is the substitution method because it is commonly used on IB exams. So I'll make sure you guys are good with the substitution method. All right, here we go.
Jesus Christ, I don't know what
I'm gonna do all of these with you. Then I'm gonna give you guys something to do on your desk. Okay, so these are all the ones that I'm gonna do. Okay, so when you look at A, okay, what is your inside function?
2x squared plus 5.
Yes, so that 2x squared plus 5, that's what you make your u. Okay, and you always know what your inside function is because you gotta think. Is there a set of parentheses being raised to something? Is there a square root? Is there an exponent? Is there a denominator? Those are usually your inside functions, okay? Because then when you take the derivative of this, what do you get?
4x plus, just 4x.
It's 4x, and then you have, your dx. And as you can see, there is your du right here, and then this turns into u. So then you'll end up taking the antiderivative of basically u squared du. And what's the antiderivative of u squared?
U to the 3 over 3.
Okay, u to the 3rd over 3 plus c. And then, of course, you can't forget to go back in and actually plug in what u was. And then that is your antiderivative of your function.
I don't know what I'm looking at, but got it.
Okay, so you want to identify what is your inside function. What is the function that you're going to take the derivative of?
The denominator, right?
Sometimes. It really kind of depends on what you're given to you. In this case, what is u going to be?
The denominator.
It is because what is the derivative of x to the third plus 2x.
3x squared plus 2.
And as you can see, isn't that the numerator?
Yes, ma'am.
So then this turns into basically du,
Over U.
which is nothing but
D.
1 over u
Oh.
du, which is what? What's the antiderivative of that?
ln.
But I need to make sure that no matter what, I always go back in and actually write in what I plugged in for you. Don't ever forget that. What about for C? What's going to be u?
Okay. E, no.
A little louder.
X to the fourth.
X to the fourth. Because what's the derivative of x to the fourth?
4x cubed.
4x cubed.
And there you go. There it is in the problem. So then this integral becomes the antiderivative of e to the u. And what's the antiderivative of e to the u?
E to the U.
Plus c.
And you just make sure that you go back in and plug in what you put in for u. So that becomes e x to the fourth plus c.
That didn't change.
Wait, where did du go? Did it get canceled out by dx?
No, remember when you do the antiderivative, the integral symbol and the du, they get replaced with the constant. Anytime you do the antiderivative, the du goes away, and here comes the constant.
Okay.
Every time.
Ooh, that never one looks fun.
Okay? What about the last one? What are you going to make u?
2x
squared
plus 5.
What's the derivative of this?
6x
squared.
Yeah.
Now, if you look, there is no 6 in front of that x squared. It's just an x squared.
So we're gonna multiply by 6, right?
Not multiply. You divide by 6. So now when you go to plug everything in, you're going to replace, instead of just writing a du, you're going to write a 1/6. So then this becomes the integral of 1/6 u to the fourth du.
Can we leave that 1/6 outside and then distribute after we're done?
You sure can.
You darn do.
So what's the antiderivative of u to the fourth?
3
Go ahead, Nicole.
1/5
1/5 u to the fifth. Don't forget your plus c. What's 1/6 times 1/5?
1/3.
And I'm going to replace u with the expression that u originally was. And then that is my antiderivative of these functions. And that's how you use u substitution. Okay, whatever the inside function is, you make it u. When you take the derivative of it, if it's not what is in the original problem, you have to adjust it so then that way it looks exactly like what's left over.
And then we should leave it like that instead of expanding, right?
Correct. Do not expand that. Leave it just like that. Okay? Let's do this one. You doing this one on your desk? All right. So this is the u substitution. What's u?
X squared plus 3x plus 1. Squared.
Nope, no squared.
No squared.
When you do the derivative, what do you get?
2x plus 1. 3. Yeah.
Don't forget about your dx, because when you go to replace it, this becomes du over u squared, which is the same thing as saying 1 over u squared du. The only way to do the antiderivative of this is u to the negative 2 du. So what's the antiderivative of u to the negative 2?
Negative
Negative u
square root, or to the power of negative.
to the power of negative 1 plus c, but I replace u with its proper thing. So I gotta plug that u of x squared plus 3x plus 1 back in, and then that is my antiderivative.
So no square.
Question.
No square, because when you brought this up to make it negative 2, remember power rule says you have to add 1. So negative 2 plus 1 is a negative 1, and you have to divide by the new exponent. Yes?
Oh,
Question?
We have to write it as the 1 over, or just leave it as the exponent.
that's what I did.
You always want to make sure your exponents are positive.
Okay.
So always turn back positive. Okay?
You're right.
All right. Let's do this one. What do I make u? Just the square root of x. Because what's the antiderivative of the square root of what's the derivative of square root of x, or sorry, x to the 1/2?
Next to the negative 1.
Don't I bring the exponent down first? Bring the exponent down first. Then I subtract 1. So that becomes what? And this also turns into 1 over 2. How can I rewrite 1/2? Square root of x. Don't you see it?
Nope.
There's a 1 in front. So here's your 1 over, here's your du. So if I use, so again, a good rule of thumb, if there's an exponent, especially with e as a base, that exponent more than likely is going to be your u. In this case, it wasn't the denominator because the denominator happened to be the derivative of the square root of x. Okay? So then this becomes the integral of e to the u du, because again, what I've highlighted in yellow is the derivative of x to the 1/2. So this becomes e to the u plus c, but I write in what I replaced u. So that becomes e square root of x plus c.
How do we lose du?
Again, whenever you take the antiderivative, the integral symbol and the du get replaced with the constant. Okay? Anytime you take the antiderivative, this is gone. Okay? Every time. These pieces will go away and they get replaced with c.
Okay, now I get it better.
Okay? Because the du, that's your constant of variation. So when you actually apply the antiderivative, that du and the integral get replaced with the actual c, which represents the constant.
So in a fraction, if the du is at the bottom, it should, or the du or the u are at the bottom, they should have a 1 over them.
They'll have to be 1 over you. Question on use substitution. All these rules, use substitution, the special rules with your linear factors, your e's, your ln's, even your power and like constant multiple rule. All those will be used again when you're dealing with the definite integral. You're still applying the rules to take the antiderivative, but you're only looking for a certain piece from one x value to another x value. This is where the bounds come in. This is where you no longer have a plus c. So whenever bounds are involved, that's your definite integral, and it represents the area that's underneath the curve. So now, instead of having the integral of x squared, now you have from 2 to 4 the integral of x squared. That means you're looking underneath the curve from 2 to 4 in your graph. That's what you're looking for. That area underneath the curve. Now, algebraically, this can either be done if the shape is of like geometric shapes like trapezoids and triangles and rectangles and things like this. We did do this back in the past. Here, from 0 to 3 of your function, it's basically asking you to find the area underneath the curve, which is this shape right here. Okay? What kind of a shape is that?
Trapezoid.
No, we got five sides. It's a pentagon. How do you find the area of pentagon? No, there's no formula there.
Don't you make it a triangle and a square?
You can make it into a trapezoid and a rectangle, or a trapezoid and another trapezoid, because that's actually slanted. Okay? Here, what's the height of this trapezoid at the bottom?
1,
What's the base?
2,
And what's this base here?
3.
Oh, like 2 point.
Hold on, I'm gonna clear it off so I can see it a little bit better. Actually, yeah, let's actually divide this up a different way.
Let's do 3s.
In 3s?
Yeah, up and down.
Okay. I'm gonna try to make this a little bit bigger so that we can see it a little bit better. How can I divide this up?
vertically.
Vertically?
Just 1. There we go.
Or I could do, or I could do 2 trapezoids. Okay, if I did it vertically. Okay, either one works. Either one works, but you would have to divide it up and take each area's pieces and add them up together. How do you find the area of a triangle?
Base times side.
So-
a base of 1 and a height of 3,
So you take half of that.
which is just
What about that rectangle in the middle? What's this area?
3.
And then for a trapezoid, remember it's 1/2 your height. What's your height of your trapezoid?
1.
And then you add your two bases. What are the sum of your two bases?
4.
4. So it's half of 4
2.
plus 3
5,
plus 3 halves.
8 halves.
13 over 2.
5 and 1. 5 plus 1 and 1/2. Okay. Making sure. Okay. Stay with me. 3 over 7 or 3 to 7. This time you're looking for this part. But this time it's underneath your x-axis, which means your area should be what?
Negative.
It's negative. Anytime the curve is underneath the axis, the area is negative.
Well, of course, we can just divide it at point, at 5, just divide it into, no.
We can do 2 trapezoids
On
and
the
a
6.
rectangle. Like we did
Vertically
last
on
time.
the 6.
Vertically on the 6.
And on the 5 too, right? Because isn't it a pentagon?
We can divide it there. So we got 2 trapezoids in a rectangle. That's how you would find your area there. That's 1/2. What's your height of this trapezoid?
3. Negative 3.
2.
It's negative 3, sorry. And then what's the sum of your two bases?
3.
What about this trapezoid right here?
Okay, it's going to basically be 1/2 times negative 3.
2.
What's the height of that trapezoid?
1.
1. Oh, yeah, 1. And then what about your bases? What are your two bases?
3 and 2.
3 and 2, so that's going to give you a 5. This does need to be negative, though, because, again, it's still underneath, so I'll make the height negative. And then what's the area of that rectangle?
Negative 2.
So then this becomes negative 9/2 minus 5/2, which is
Negative 16. No, negative 15.
Negative 14, yeah, negative 7,
so negative 7 minus 2 is,
negative 9.
there we go. And then you continue on from there, okay? You continue on from there, making sure that you go the full gambit from 0 to 7. You're basically adding the orange area to the purple area to get a negative area. Okay? These were also some of your properties of definite integrals when it came to in general. Okay? Anytime you have the bounds from A to A, the antiderivative is always 0 because you're not covering any area that's underneath the curve. Whenever the bounds were reversed, for example, let's say you were doing the integral from 0 to negative 2 of your function. Remember, it always went from left to right. If you go from 0 to negative 2, you're going right to left, which you can't have. So you can switch them by negating the entire function. Okay? That's what this rule was right here. Anytime the bounds were backwards, you could always negate it and turn them the right way. From A to B of your function plus B to C of your function gave you from A to C. This always happened whenever your function went below the x-axis and you had to split it up because you're looking at the area underneath the curve in between the x-axis. Down here, this is nothing but the sum and difference rule. Okay? You have a function plus another function. You just evaluate the bounds for both after you take the antiderivative. The constant rule, and then, of course, the constant multiple rule. Again, those same rules from before, they apply, it's just now you're evaluating it with bounds. Now you're evaluating with bounds. So, for example, if you're given that the integral from 1 to 3 of your function is 2, and from 1 to 6, your function is negative 3, how do I find from 3 to 6?
Get negative 3 and subtract 2.
And why do I do that?
Because 2 plus that number equals negative 3.
Exactly. Because you have from 1 to 3 and then 1 to 6. And you're trying to find from 3 to 6. So, -3 minus 2, and that would be -5. Very good. Look at this one down here. You have from 0 to 2, it's 5. From 4 to 6, it's -2. And then from 0 to 6, it's 7. How do I find that missing piece from 4 to 2?
Okay, let's get 7 and subtract 5 and -2.
So then what is the area from 2 to 4?
4.
You would add these
7
together.
minus 5 is 2, and then you add 2 to get 4.
That'd be 4. Very good. Okay? What if you had something like this? I'll make it a little bit bigger. You're given that from -1 to 1, the area is -4. So what is A?
4.
Just 4.
It's +4 because look, the bounds are what?
Inverse.
They're reversed. So if you want to turn them the right way, you basically multiply by a negative. What about this one here? For
It
B?
is 0 because you just add was 2 by 2, which is 4.
You're adding a space underneath the thing.
Mm-hmm.
Aw, man.
So y'all remember this? Visually, you're basically going from -1 to 1. Whatever your function is, you basically added 2 spaces. So now your function, whatever it is, looks like this. So you basically added a 2 by 2 square underneath, which is an area of 4, because you multiply. And then, of course, the integral from -1 to 1 of your function was, so your answer is 0. Very good. What about the next one?
It's just -8.
So it'll be -8 because there's nothing but your constant rule. So then you just double. That's how you get 8. And then what about this?
Okay, let's just
Oh,
get
that's the
7 and
scalar
divide by
multiple.
-4, which is just -7/4.
Very good. This is nothing but a constant. It's nothing but a scalar. So since you know that this is equal to -4, you solve and k is equal to -7/4.
Oh.
Very good. And this is how you would do it algebraically. All those other ones didn't have a function involved, but when you do have a function, you take the antiderivative and you evaluate it top bound minus bottom bound. We'll only do a few because I know we're running out of time. When you do the antiderivative of 2x, what's the antiderivative of 2x?
X squared.
Very good. X squared. You evaluate it from 0 to 1 by plugging in your top bound, subtracting it from when you plug in your bottom bound. So what is my area?
1.
Very good. Okay? You take the antiderivative first, then you take your antiderivative first, and then you apply your bounds. What do I need to do here?
Oh, foil.
So once I FOIL, then I can take the antiderivative. What's the antiderivative of this function?
T cubed over 3 plus, t squared.
2t squared.
Plus
3t.
I'm going to evaluate that by plugging in which bound first? 1. And then when I plug in my lower bound, I'm going to what? Subtract it. And even if this wasn't a 0, because of course every term would cancel out, you make sure that you distribute that 0 all the way across that entire second part. Don't forget to do that. And then you'll get your area. Of course, you can interpret or incorporate any of your other rules involved. Okay? So don't let that throw you off either. What's the antiderivative of 1 over x?
ln of x.
So if I'm valuing this from 2 to k, which bound do I plug in first?
K.
So this becomes the ln of k,
Minus ln of 2.
and all of this should equal the ln of 6. Now be very careful. How do I find the value of k? What do I need to do?
K over 2.
You need to do 6 multiplied by 2.
Well, ln K over 2.
Okay, you can do the ln of k over 2. It will equal the ln of 6. Remember your rules of natural logs. If they equal each other, you can just what?
Cancel out the ln.
And so you have k over 2 is equal to 6. So what is k? 12. Very good. You could have also added the ln of 2. Remember, when you add with exponentials, you multiply them. That's how you end up getting 12 there as well. Okay? I will stop there for today. But we pretty much reviewed all your basic rules when it comes to integration.